Mating to this controller is our main harness. In the case of a steer ready machine, we're going to have what we call our ISO machine main harness. And this will mate up to our iBox controller. We'll have a click in the controller. This is usually done after the controller is mounted properly. The first connector is X19. It's a 12-pin Deutsch Mini. This is used for GPS connections if you have a GNSS receiver for GPS guidance, and or also for speed if there's no vehicle speed available. The next connector is labeled X01. This is used for the sensor guidance. So for example, on a case combine, there would be an adapter that mates to this connector and goes to our tack sensor up in the corn snout to follow the corn rows. The next connector is labeled X14. This will mate to an adapter that goes to a rocker switch for powering on and off the system, for operator indication that the system is engaged, and as well as the possibility of using the button to engage the system. And then the last connector is X31, and this will mate to a ISO machine adapter. There's a collection of machine adapters available, and they're specific to each machine. So in general, the same core components will be used for every steer ready machine, with the exception of the machine specific adapter. As you can see right here, we have our iBox MC controller. That's the main brain box that'll take all the inputs from our road guidance sensor and communicate with the combine to steer it. A mounting plate to mount the controller. The controller has 6-axis inertials, so the mounting is going to be very, very critical for the installation. We'll touch on that. And then some mounting hardware to go with that. The bolts that mount the controller to the mounting plate would require a 11mm wrench or socket set. Each kit will have a unique mounting plate based on the cab style for mounting the controller, and the orientation of the controller is going to be very, very important. We'll discuss that in the cab a little bit more in detail. You need to line up the holes. We'll have 2 threaded 7mm holes in the plate, and then additional holes for mounting to the machine. You want to line up the controller with the holes, use the lock washers, and then line up your bolts. Some downward pressure may be needed with the lock washers to get the thread started, and then thread those into the plate. Using an 11mm wrench or socket set, tighten the bolts up to the plate. In some instances, it's preferred to mount the plate to the machine first. In other instances, it's better to mount the controller to the plate first. Depends on the installation. For today, we're going to mount it to the plate first. In a common cab combine, you're going to see a cover over this corner, and then you can remove this cover. This is where our controller will mount. In a non-common cab combine, this would be all open. You'd have flooring right here, and then there'd be 4 bolts where we add a plate and mount our controller to that plate. A final mounted controller would use a specific plate for this machine using an existing bolt pattern, and then our ECU would mount to that with the hardware shown earlier. We want to make sure that this thing is mounted square to the machine, square to the earth. What I mean by that is a 90-degree angle, and then there's a pre-configured position that would be entered into the system. This orientation shown will be the standard mounting for the common cab CNH combine, where the connector is facing straight back with the label facing straight up, as shown. And this is the rear of the cab. So with the cover removed to the right of the driver's seat, you can see our controller is now mounted with the connector facing towards the back of the cab using a standard bracket. Our main harness goes to an adapter that will Y into the armrest connection, and just make sure that the harness loom that goes up to the armrest then follows the existing loop from the armrest, as you can see with zip ties. There's extra length provided with the adapter so that it can follow the full length and sneak in and out at the same point as the armrest harness. That way it's secured, it does not have any binding or stretching of the harness. And from here you also have your other connectors, your X01 to your row sensor, your GPS connector if you're going to do GPS guidance, and your armrest switch harness. And these can also route out of this area. For exiting the cab, There's spots out the back, out the floor, out the side. From the main harness, there's connector X14. This would mate to the armrest adapter harness. And this would go to a rocker switch to power on our system, engage our system, and so on. With our armrest adapter harness, there's an extension harness available. This is for routing to the armrest and for accessibility. If you needed to disconnect the harness, this makes life a little bit easier. The reason why these are not populated in the connector is so that these can be routed through the armrest. This connector will be typically in the armrest or somewhere in the cab, and then this is routed out to the main harness. These wires need to be populated into the connector provided with the harness. On this harness there are 5 unique wire colors, and each wire is stamped, labeled X14 and then the terminal number. For terminal 1 we have a brown wire, it's labeled X14 terminal 1. And we will populate this into terminal 1 of the connector. You want to put this through the connector until you hear a click sound, and then do a little bit of a pull test to make sure that it's fully populated in the connector. For terminal 2, there's an orange wire labeled X14 terminal 2. Again, these wire colors and numbers are all referenced in the installation manual. Terminal 3, orange with red. Terminal 4 is the white wire, which comes around here. If you look at the face of this connector, you'll see the terminal numbers here on the edges. Terminal 5 is a gray wire. Again, click and pull test on all. And then lastly, we need to put the secondary lock into the connector. Usually a needle nose pliers would work for this purpose. Press that in, click, and just make sure that all the pins are fully populated. From here, you mate X14 to the main harness, or use the added extension in between. On the other end of the armrest adapter harness would be the armrest switch. There are 2 different switch options available depending on the platform kit. The one here shown on the left would have a 2 position where you have power off, power on. There's also 2 LED indicators for when the system has power, as well as when the system's engaged. The other switch is a 3-position switch. This has power off, power on, and then a momentary press for engaging the system. Again, the LED indicators are consistent with the last switch, both of which would mate to the X22 connector on the armrest switch adapter harness. The most important thing about mating this is you'll notice that on the switch there's a tab, and then there's no tab, and then you have bumps on the switch adapter. We want to make sure that the tab lines up so that there's no interference. It is quite difficult to plug this in backwards, however we have come across situations where they can be, so you just want to be cautious that it's mounted in the correct position. Normally this is routed through the armrest, this is mated, and then populated in the armrest. You just want to work it down until you press it, and you'll hear clicks, and these 2 locking tabs on the front and back surface will lock the switch into place. So the first part of the physical harness connection would be the main controller to the main connector of the main harness. The connector for the controller, it's a 42-pin slide lock connector. You'll notice that there's notches on each end, and you have bumps on each end of the controller. You want to make sure that those are mated up correctly with the connector locking tab slid out fully. And then while applying light pressure, slowly slide in the tab until you have a click. You would do this after mounting the controller in the cab typically. From the main harness, if we follow the harnessing out, it starts and splits off to 4 different connectors. The first connector is X31, which is the main connection that goes to the machine, as we discussed, for CAN bus, power, all those connection points. That will follow an adapter, and then that adapter will connect into the cab. In the case of the Case Common Cab Combine, it will be into the armrest of the cab. The next connection point, it's a 12-pin Deutsch Mini connector. It's going to be or it is labeled X19 for GPS. In the case of this installation, we will not be using this connector. That would go directly to a GPS receiver. The next connector in the main harness is labeled X14, and this is used to connect to an armrest switch for powering on and off the system, as well as provide things like engagement, engage signal, engagement indicator lights, things like that. If you follow the harness, it routes up to the main rocker switch. A mounting kit is also available for this switch to mount outside of the armrest if needed. And then the last connector on the main harness is labeled X01. It's for our sensor guidance. In the case of this installation, we will be using our TAC row guidance sensor. There will be an adapter harness to go to the proper connector for the sensor, and then followed by extension harnesses to route out to the sensor outside of the cab. Following that, we will plug directly into our TAC sensor. We'll just touch on the user interface, the setup of the Reichhardt system in a newer case combine. First thing we need to do is power on the machine. And you'll have a screen load up. And at this point on the screen, you would navigate to the virtual terminal menu. Each screen will vary slightly. In the case of the AccuLeader Integra, there will be a bar at the bottom that says VT. Just select VT. At this point, if you're powering up Reichhardt for the first time, it'll actually upload its user interface to the display. So when I power on the Reichhardt with the rocker switch, you'll hear a click in the controller. And at this point, it should connect to the display and start uploading its object pool. Each display is a little bit different. We touched earlier in the cab of the case combine, there's an icon that showed this. On the AccuLeader display, it's shown by this bar sliding left and right. This process takes anywhere from 2 to 5 minutes depending on the CAN bus load on the machine. So once the Reichhardt system is uploaded, you'll see the object pool pop in, and you'll see the tab here for the Reichhardt as well. Again, each virtual terminal display will vary slightly, but in general, you'll have a working set icon. It'll look like this, a steering wheel with 3 dots and 3 lines. The background color will vary based on the state of the system. Typically, it will be red for the first time use because it's not configured for use. And then you'll have a disclaimer page. This will pop up every time the Reichhardt system is powered on for safety reasons. You just have to press the OK button to confirm. When you enter the screen, you'll see our main user interface. Typically there will be error codes. The way you can tell this is when you hit this red button, a bunch of different error codes will pop up. This is simply because the system's not yet configured for use. You can just cycle through by pressing the escape button to clear all the error codes. At this point, we can begin the setup of the system. As long as it's properly connected to the machine, we can go in and configure it for the machine, do all our calibrations, and that should clear out the error codes and make the system ready for use. Press and hold the wrench button for 2 seconds. From here, we need to enter in a PIN code. Select PIN. Here we want to enter in an access code, so select the box where it says code. And here we'll select 7371. Press OK. Press OK again. The system will beep twice to notify that the code was received. That code is a temporary access code. If for some reason a vehicle code is changed or the system is power cycled, the system will automatically relock. So be aware that you may have to go back in and re-enter this code multiple times during a given setup. The next area that we need to travel to is the Teach-In menu in the top left corner. And this is where we can do the full configuration for the machine. So select Teach-In. And we'll just work left to right, top to bottom down the list. So the first thing we need to enter is a vehicle code. So we select icon A for the tractor icon. And here's where we enter in our code. A nice new feature with the system software is you can actually name the vehicle code. So for example here, I can tap the pencil icon and enter in a name. So here I can put in case, I'll go 8230 for example. And hit enter. So we can put a name in. Next thing we want to do is enter in a steering mode for a newer case combine. We're going to use a CAN bus steered machine, which is a 4 for the first box. Vehicle class, if it's a newer case combine, will be 231. If it's a pre-common cab case combine, it'll actually be a code of 230. And right here would be the completed Teach vehicle code entry. At this point you press the OK button. It'll take you to a save screen. And here you want to press OK on the save icon. The system will beep twice to confirm saving. Once the save button has been entered and you hear the double beep, it sets the entire system to defaults for that vehicle code, which means all calibrations and setups are back to default, would need to be rerun if you ever enter that code in and override it. The next icon over is the angle sensor icon, B. And here's where we can go and enter in a angle sensor calibration. So this is for calibrating the rear axle wheel position for left, middle, and right positions. And what we would do here, since we're not on an actual combine, these numbers will not update. But what you'll see here is an actual value reading from the sensor, a left, center, and right calibration. And what we would do is turn the wheels all the way to the left stop on the combine and then press set, and it would set the actual reading from the sensor to the left. In this case, let's say, for example, it could be 200, and then 200 would be set here. And then you would straighten out the wheels, try to drive as straight as possible, make sure the machine tracks straight, and set your center position, and that would overwrite your center position. And then turn it all the way to the right stop, and go ahead and press set for right. So you would have 3 unique numbers based on the readings from the sensor. This number would change as the wheels are moving, and you would have a left, center, and right. The reason why the area on the top is grayed out is because it's a CAN bus steered machine, so we don't need to configure the sensor type or signal type. And we know that it's a only single or one angle sensor machine. So this is grayed out because it can no longer be selected. The only thing that we need to do in this menu in the case combine are the left, middle, and right calibrations. And then to save your changes, you press the OK button, you press OK to save it. The next icon over, icon F, it has a V in the corner. This is for our speed input. And by default, we have a vehicle-specific message that we can read off the combine to get speed. Typically, we can skip this menu and leave this alone. However, if you want, you can add additional options for speed sources. For example, you can get one from a connected GNSS receiver. The next icon over, letter G, is for the internal tilt sensor. For our system, we have a internal 6-axis terrain compensation, and it's very important to enter in the proper position of the sensor based on the mounting position in the cab. For our newer cab case combines, typically this is going to be a mounting position 1. There is documentation with graphics that can show which orientation would be used for each machine. Refer to your installation manual and mounting instructions for those specific numbers. In addition, to do a calibration of the tilt sensor, we first want to enable tilt by selecting the checkbox. And now you'll see a calibrate icon. You can select calibrate. It'll take you to a new menu, and it'll take you to a menu where it says teach terrain sensor. At this point, you want to mark your position of the combine, either in a driveway or in a yard or in a field. Mark where the front tires are on the machine. When you press OK, while not moving, it'll calibrate these values. Once it's calibrated, you turn around the machine facing the opposite direction with your front axle in the same footprint. And what we're doing is compensating a roll angle bias of the sensor. So now once this is turned around, you want to turn the combine around facing the opposite direction, same footprint for the front wheels or front tracks. And once that's in place and at rest, go ahead and press the OK button again. You press OK again, it'll save, and you'll hear the system beep twice. And that will complete your calibration. Your next icon over is for operator presence. Since there are existing safety cutouts in the machine, we typically have this turned off, but if desired, you can wire up an additional seat, door, or rocker switch for this input. And refer to your installation instructions for more details on this. The next icon over is for entering a configuration for a foot switch input, which is our manual engage switch. On the newer case combines, there's already Engage functionality built into the CAN bus, so usually this is not wired up or utilized. Go ahead and skip this step by just not entering that menu. The next icon over is Offset, and here's where we can put in the geometric data of the receiver mounting on the combine, and this is utilized for terrain compensation, line acquisition, and other GPS guidance functions for GPS steering modes. This will directly impact the performance of the system in terms of maintaining a good level of deviation with the guidance system, or a minimal deviation, as well as line acquisition with GPS. What we want to do in this situation is just measure out all your offsets. So this would require a tape measure, and again, refer to your installation manual regarding how to measure and how to reference these different measurements. You simply select one of the icons, one of the text boxes, enter in a numerical value. So for example, here if I put in a 3, that's stating that the receiver is 3 inches to the right of the center of the header position. Once you've entered in your proper offsets, you press the OK button, and you press OK to save. The next icon over is for turning diameter, and what we do here is just turn the machine a hard left and measure from inside track to outside track. Again, reference your installation manual for more information on this, but it's just the diameter to turn the machine all the way to the left as well as to the right, and here you can enter in the actual numeric values. The values shown here are based off of defaults from the last machine that was tuned, but of course this will vary based on machine to machine, based on wheel spacing and different geometry of the machines, tracks versus wheels, etc. And then to save your changes, you'd again just press the OK button. The next icon below looks like a picture of a joystick. Currently the joystick is off. This allows the functionality for additional features like aux for engaging the system, nudging, things like that. In the case of the case combine, there's already an existing Engage switch, other functionality. It's not too common to have an aux joystick in a combine, so typically we would skip this step. And then the last icon, it says TL Top. This would be integrating the Reichhardt system with a Reichhardt branded or specialty branded Mueller Comfort display or Touch ME display, and that will allow you to do curve guidance along with mapping. Currently it's not commonly used, so we'll skip this step as well. So in summary, for the teaching of the system, primarily the main things you will be doing is entering a vehicle code, doing an angle sensor calibration, and doing a tilt calibration of our controller. The additional steps which are optional would be new speed input, safety switch, engage switch. If you're doing GPS guidance, you'll need to enter in an offset and a turning diameter, and then the bottom 2 icons are not very commonly used. So once the whole system is set up, we were originally in the teaching menu, you press the escape button 2 times and you'll return back to the main screen. When you put in a vehicle code for a common cab case combine, you'll notice that the bottom center icon now looks like a corn snout with our tach sensor. That means we are in tach steering mode by default. We can also switch over to GNSS guidance by pressing and holding the steering wheel icon with the 3 orange dots. And after a couple seconds, it'll move up a few spots, start flashing. And at this point, you can use the plus or minus keys to change the steering mode. So here I now am in GPS. You'll get error codes if you don't have GPS signal or any configuration of the GPS. But now we're in GPS steering mode. Switch back, press and hold the icon, and scroll over there to TAC. So for TAC row guidance, there's some basic calibrations of the sensor. As you can see here, we have an example of the sensor plugged into the system on the screen. To tap the wrench button will take you to the TAC configuration menu. And here you'll see the readings from the TAC sensor. Looking forward, this would be the left side, and this would be the right side. This is TAC 1, this is TAC 2. You just want to verify and make sure that this sensor was not wired incorrectly or put in backwards. Make sure that TAC 1 is on the left, tack 2 is on the right, and that you have good moving ranges with the sensors. Typically the reading, what we call our neutral reading of the sensor, is when we're not in corn, and this is how we filter out areas of the field where we don't see corn with either side of the sensor. We do a calibration. Here below where it says calibrate, if you press calibrate, it'll take the readings from the sensor and set them to the darker boxes below. And those are what we call our neutral reading of our tack sensors. Over time, the sensor itself, the paddle itself, may have a natural curl to it, and so the neutral readings may actually go up. And this is why we have this calibration. So for example, maybe after a year you have a neutral reading of 68, 69 here on tack 1. If you hit calibrate, now it sets it to that value. Below we have advanced settings for our tack configuration. If you press advanced settings, we have some additional fine-tune adjustments. The number one setting for a harvester would be the roll angle compensation. Currently it's set to 25%. You can increase or decrease this value to make the system more or less responsive to side hill. They also have a pitch angle, and if you're using one of our newer controllers, it'll respond to a pitch when the machine is leaning forward or back to soften the amount of correction that the system would typically make. In addition, we have some sliders for response of the system and stabilization of the system. Typically these are not needed to be tuned on a harvester. They're more for higher speed systems, for example self-propelled sprayer with our row guidance. To save your settings, you press the OK button and it'll take you back to the previous menu. At the bottom we have a mode entry. We have 3 different modes for our system. We have straight, curves, and combi. Straight is designed for a guidance system where we know we're going to do row guidance and row guidance only in straight planted rows. Curves would be in a field where you have a waterway or a terrace or any kind of a non-straight pattern. It'll allow the system to be more aggressive in a curve. You can leave the system in curves mode while in a straight pass. The steering will still perform in straight, but again, we have those 2 options. If you want to have something that's fixed on limiting the steering for straight rows, you may get slightly better performance in a straight field with straight mode. And then the bottom option is called combi mode, and this would be a solution if you are guiding with both GNSS, GPS guidance, and with sensor guidance. And what combi mode allows you to do is enter in a working width. So for example, let's say we have a 12 row, 22 inch header, put in 22 feet. And what that allows us to do is enter in that width, and when you're guiding with the system down the row, it'll create an AB line in the background of the system. When you disengage the auto steer and turn around halfway around the headland, the system will beep and actually automatically switch to GPS. And it'll allow you to GPS guide into the next row based off of the next line 22 feet over, or if you're taking multiple passes, you can go 44 feet, 66 feet, etc. When you engage it, it'll guide with GPS into that line. Once it's on that line, it automatically switches back to row guidance. Once you have your desired mode selected, as well as your advanced settings and your tack calibration completed, press the OK button. The system will beep twice to confirm the changes, and it'll take you back to the main screen. You'll notice that I selected straight mode. It'll say straight on the bar right below where the tractor icon is. Other settings would be general use settings. Refer to your main operator's manual for how to adjust things like reaction of the system, nudging of the system, as well as we may have some additional video resources and or manual documentation on how to set up GPS guidance lines. You go into the system, you power it up, hold the wrench, put a pin code in, go to the teach-in, put in a vehicle code, do an angle sensor calibration, do a tilt calibration, and then go in here and do a tack calibration. Done.